All right, books open to page 136, and you did just two problems. At the top of this page, number 23 and number 27. And Brandon, number 23, what do we need to do? Into?
2 by x squared positive 9 times x squared negative 6 equals 1.
There we go, check the outer inner, it checks out. Then Abby?
You set each equal to 0.
To get?
X squared equals negative 9 positive 6.
And then what do we have to do next? Genesis? To get?
X equals I times square root of 9i.
Well, you're right about the I times the square root of 9, but the square root of 9 is 3, so we could just say
3i.
There we go. We're half right with that. There we go. Positive negative 3i. Then over here.
X equals positive negative square root of 6.
Yeah, we can't really do anything else with the square root of 6, so we have 2 real irrational answers, 2 imaginary answers. How many have those 4 roots for number 23? Questions on 23. Number 27. What do we need to do first on this problem? Kendall?
Change the 1/2 to 2/4.
Good, that's a good way to start. Make sure they have matching denominators. So instead of the 1/2 power, the 2/4 power, then what?
You can backwards FOIL.
We could, but I'd rather do something first to make it a little easier. So the changing the 1/2 to 2/4 was a move to make it easier. There's one more move we could make.
You can pull out a 2.
That's going to make everything easier. So I'm a big fan of that. What would we have now?
X to 2/4 minus 5x to 1/4 minus 6.
There we go. And then the backwards FOIL becomes that much easier. Michael, we would factor into
x squared fourth, x squared fourth. Positive negative 1 and 6.
There we go. And then turn that into 2 little equations, Audrey.
X to the 1/4 equals negative 1. And x to the 1/4 equals 6.
And then what we'll have to do to finish it, Audrey?
Raise it to the 4th.
Right, raise everything to the reciprocal power, which the nice thing is the reciprocal is just 4. So raise everything to the 4th power. And that gives me x is equal to
1.
And x is equal to
1,296.
yes, 1,296. One of those I have my suspicions about. Which one, Maddie? The 1, which is a shame because that's the easier number. But because it was a negative change to a positive, it could work. I'm not saying it doesn't, but I'm a little suspicious. I'm a little less suspicious of the big ugly one. So let's try the 1 here. Again, going back to what this was 2x to the 1/2, or 2 times the square root of x, if you will, right? That's what the 1/2 power means. Minus 10 times the 4th root of x minus 12 is equal to 0. And of course, we know the square root of 1 class is, times 2 is 2. 4th root of 1 class is 1 times negative 10. Negative 12 equals 0. No, and again, I already kind of was suspicious that might not work. Calculators at the ready. What the square root of 1,296 times 2. 4th root of 1,296 should be screaming at us from right here. 6, right? Times the negative 10. Negative 16, of course, minus 12 is equal to 0, and yes, that one checks out. So just the one answer works, the 1,296. How many have that answer? For number 27. Questions on that? Questions on either of those 2? Again, that's kind of a review of stuff we've been working on for the last couple of lessons, not really new to what we did yesterday. Questions? All right, flip back then to page 134, so just turn a page back. Page 134, this was the stuff we've been working on yesterday, working with these rational exponents on polynomials and dealing with those. You did the teal problems in that top section on the page, starting with number 21, where we had an x minus 2 to the 2/3, all equal to 9. What did we need to do here, Maddie? Well, raise it to the 3/2 power. There we go, which here you are going to multiply the exponents and which was the whole point of the reciprocal, right? That'll give us x minus 2 is equal to 9 to the 3/2. Now you could put that in the calculator, but I gave you a word of caution. Anytime the denominator is even, meaning an even root, there's technically going to be, class, positive negative. Now there will, if it's like an 8, there will be 8 different roots. A positive, a negative, an imaginary, another imaginary, and 4 complex. Okay, forget all of those. We can't check those. But at least get the positive negative from any even denominator or any even root. We could probably do this in our head though. The square roots of 9, positive, negative 3, and when you cube positive and negative 3, you get positive and negative 27. Again, if you put in a calculator, it's only going to give you 27, so you've got to know positive, negative on the even denominators. Then from here, we'll add the 2, and what 2 answers do we end up with here, Maddie? Good. How many of those 2 answers on number 21? Excellent. Let's go to 22, and we have a v positive 5 to the 2/3 is equal to 25. Pretty much the same kind of thing going on here, Kendall.
You raise it to the 3 half.
Yeah, and of course here those cancel. I get v plus 5. 25 to the 3 halves?
125.
Half, right?
Positive.
Yeah, because again, even denominator is going to give us the positive negative 5, which we have to cube both of those. And of course, we'll just subtract the 5 away to get what 2 answers for v, Kendall?
130 and 120.
Well, you're right on the 120. Careful, negative 125, negative 5.
Negative 130.
Negative 130. How many had 120 and negative 130 on 22? Number 25, this changes it up just a little bit. We've got it, that's an x. X positive 9 to the 2/5, all equal to 4. Michael?
You need to raise it to the 5 halves.
There we go. And again, these are going to cancel if we're the reciprocal exponent. X plus 9 equals, again, we got to take the square roots of 4.
2.
Now, technically,
Positive negative.
positive negative 2, raise those to the 5th.
32. Positive negative.
There we go. When we subtract the 9, we get what 2 answers for x?
You get 23 and negative 41.
How many of those answers for number 25? Questions on that one? All right. Let's see. Give myself a little bit more room. Next teal was 28, where we had 5c plus 16 to the 3/4. That's a 3, just didn't look like a 3. Equal to 27, and let's go to Abby.
You multiply everything by the reciprocal of 3/4.
What does she mean, class? Raise it to the 4/3 power. Raise to the 4/3 power. Again, the multiplication happens with these exponents, but I'm not multiplying this by 4/3. I'm raising to the 4/3 power. But I know what you meant. I'm just helping you to say it more clearly. So over here, of course, I get the 5c plus 16. Do I need a positive negative here, Abby? No, because there is only one, well, there's two complex roots, but there's one real cube root of 27, and it's only 3. And when you raise 3 to the 4th power, you just get 81. Then from here, 2 steps.
Subtract 16 and divide it all by 5.
And you end up getting what for C?
13.
That's what I was getting as well. How many else? You got 13. That's what the book got. That's a good sign. All right, questions on this? All right. Number 33. This one, it makes itself look scarier, but it's really not. 7a minus 4a plus 2 all to the 2/5 power equal to 4. Let's go to Brandon.
Multiply and raise to the 5 halves.
Good. Raise both sides to the 5 halves power. You could say raise everything to the 5 halves power, but it's because there's only 2 things. Generally, both sides. And on the left side, what do we get?
3a positive 2.
Good. These cancel, so it just gives me this, but let's also combine at the same time to get 3a positive 2. And on the other side,
Positive negative 32.
there we go. Square roots of 4 are positive negative 2 to the 5th is positive negative 32. 2 steps.
Move over the 2 as a negative and divide by 3.
All right, so there's 2 different answers here, right? There's the 32 minus 2
30.
divided by 3.
10.
And there's a negative 32 minus 2
Negative 34.
divided by 3.
Negative 11, 1/3.
I was just going to say negative 34 thirds, but negative 11 and a third would work as well. How many got those answers on number 33? Questions on that? Number 36, also ugly. And Genesis, what do we do on this one?
Take the, multiply both sides by 3/5.
Well, class, raise to the 3/5 power. There we go. We're raising to a power. But yeah, we end up, again, these exponents we multiply, because when you raise a power to a power, we multiply. But again, we're raising to the 3/5 power. What do we end up with on the left?
11k minus 47.
There we go, combining those like terms. And then here, the 5th root of 32. We'll go way back in our minds, class. Positive, negative 2? No, with an odd exponent, odd root, it's just positive 2, and then 2 cubed, 8. All right, then what?
Add the 47 on both sides and divide by 11.
And we end up with k equals 5. Works out evenly. How many k equals 5 on this one? Number 37. Let's combine all the x's real quick, class.
15.
I got a 15x, there we go. Plus the 46, and it's all being raised to the 3/4, so we're gonna raise it to the 4/3, so it's just gonna be that. Then on the other side, we're gonna raise 64 to the 4/3 power. Again, that means, class, we're gonna take which root? The cube root of 64, and then we're gonna raise that 4 to the 4th power. All right, then from there, Audrey,
You subtract the 46
to get,
to 10,
and then,
divide 15 to 14.
and there we go. And how many had the 14 there for number 37? All right, questions on the homework. Are we starting to get more comfortable with fractional exponents? How to use them, how to read them? Questions? All right, well, obviously we have been working through all kinds of equations lately, and we're going to progress to another kind of equation. We're going to revisit absolute value equations. So next section in your notes, absolute value equations, part 2. Absolute value equations, part 2. Remember, the key to absolute value, class, is isolate absolute value, then set equal to positive, negative. Isolate the absolute value, set equal to positive, negative. So, real quick refresher, we'll get it in your notes since it's been a few weeks since we've done one of these. We had a really easy absolute value equation, like the absolute value of x plus 2 equals 5. What would we need to do here, Maddie?
Make 2 equations.
Okay.
X plus 2 equals 5, and x plus 2 equals -1.
There we go. And when we solve, we get what 2 answers for x? Anyone?
3 and negatives.
There we go, 3 and -7. Okay, questions on this as you're kind of refreshing your memory. Remember basic absolute value equations. The only twist we're going to do to these now is we're going to introduce quadratics into the absolute value, but the steps won't change. Write this down if you would. The absolute value of x squared plus 2x is equal to 5x positive 10. You can see there's a square. That's going to make this quadratic. But the steps are still the same. We isolate the absolute value. It's isolated like it was before. We make 2 equations, as Maddie said, set equal to positive, negative. What will those 2 equations be, Brandon?
X squared positive 2x equals negative 5x negative 10. And then x squared positive 2x equals 5x positive 10.
There we go. We said equal to negative that. We said equal to positive that. Notice all the signs change when you do the negative. All the signs stay the same when you do the positive. Okay? But we've even seen that before. We've just never seen a squared in it. Well, it's a quadratic. What should we do now? Anyone? What do you think?
Set equal to 0.
And factor. Set equal to 0 and factor. I mean, we've been doing. So it's really not any harder than what we did before. We got to bring everything over here. And what does it become on this this left-hand side, Michael?
X squared positive 7x positive 2.
And then over here, when we send the 5x and the 10 over, Abby,
X squared negative 3x negative 3.
There we go. And of course, then we need to factor, right? And how will we factor this trinomial here, Genesis?
X plus 2 and x plus 5.
And then the other trinomial will factor, Kendall, into...
X and X, positive and negative. 5.
What's the most natural way to split a 10?
5 and 2.
Let's try it. All right, check your iterator. What does it give you?
Positive 3.
Oh, so all we need to do is,
Change that.
there we go. Yeah, don't belabor backwards flow. Plug in some numbers, see what happens, and change it if you have to. Now, when we set each one of these equal to 0, notice class, we're going to end up with 4 possible answers for x. What are our possible answers for x going to be, Audrey?
Negative, positive, -2.
Well, I'm gonna write them separately for reasons you'll see in a minute. So positive 2 or negative 2 from here. Wait, positive and negative 2?
Just negative.
I'm getting a pair of negative 2s from that.
And then positive, -5.
Pair of a positive and negative 5. Negative 5 from there, positive 5. So I've got a negative 2, a negative 5, a positive 5, and a negative 2. Now, notice one of the answers is redundant. We don't need to bother with duplicate answers. Okay, so we can cross out the duplicate. There's nothing wrong with it necessarily. It's just we don't need to write it twice because we're lazy. But that gives you 3 distinct other roots that would need to be checked. Remember I said anytime there's variable inside, variable outside, we've got to check. So let's try these numbers. Let's start with the negative 2. They doubled down on it, so let's try it out. If we square a negative 2, class, 4, and then 2 times negative 2, 4, negative 4, absolute value of 0. 5 times negative 2, negative 10, positive 10. All right, so the negative 2 checks. Let's try the negative 5. Negative 5 squared. 25, 2 times negative 5. Negative 10, 25, negative 10. Absolute value of 15. 5 times negative 5. Negative 25, positive 10. Ooh, negative 15. So the negative 5 does not check. Let's try the positive 5. 5 squared. 2 times 5. 10. I wasn't mentally prepared, I'm sorry. It's been a couple weeks since I've heard that. 10 and positive 25. 35, absolute value 35. 35. And 5 times 5? Plus 10. All right, and so that one checks. So of my 4 roots, 1 is a duplicate, and then 1's an extraneous, and we've got 2 working roots here. Got the negative 2 and the positive 5. So again, we've even seen the checking thing before. Whenever there's variables that are inside and outside, it just means we've got more things to check. And the possibility, not always, but the possibility of duplicate answers, which we just kind of cross those out as we go. Questions on this? All right, page 138 in your textbooks. Page 138 in your textbooks. And let's go and take a look at number 5. Copy it down on your paper. We'll do it together. Page 138, number 5 at the top of the page. X squared positive 3x absolute value is equal to 3x positive 9. And again, anytime we see absolute value, 2 key steps, class. Isolate the absolute value, set it equal to positive, negative. All right, so let's make those 2 equations. Genesis?
X squared plus 3x equals negative 3x minus 9. And x squared plus 3x equals 3x plus 9.
All right, and let's take a look at the first equation. What do we need to do here, Abby?
You need to move the 3 over as a positive 3, and then move the 9 over at the same time. So x squared plus 6x plus 9 equals 0.
All right, what about on the other equation, Kendall?
X squared, 1.
Help, class? Those 3 x's cancel, and it just gives me x squared equals 9, which actually works out great, Kendall, because that's incomplete.
X equals 3.
X equals positive negative 3. All right. And over here, thoughts on what we should do here, Michael?
You need to factor it,
Okay.
and you get x plus 3, x plus 3.
Good, or x plus 3 squared, but I like the x plus 3, because that gives us what roots here?
Negative 3 and negative 3.
And of course, we already had a positive 3 and a negative 3. They're not just doubling down, they're tripling down on this whole negative 3 thing, so I'm pretty sure it's going to check. We can cross out a couple duplicates here. Let's just make sure the negative 3, they're not triple wrong here. Negative 3 squared, class? 9. 3 times negative 3. Negative 9. 9 and negative 9, of course. 0 absolute max. 0 is 0. 3 times negative 3. Plus 9. 0. Okay, yeah, so this one does check out. Let's try the 3. 3 squared. And 3 times 3. 9 positive 9. Square root of 18. Or absolute value of 18, excuse me. 18. 3 times 3. 9 plus 9 is... Alright, so no extraneous roots. A couple of duplicates, but no extraneous roots this time. Do you understand the process of what we're doing here? Are there any questions before you try a couple on your own? 8. And let's just take these one at a time. Do 8 at your seats. We'll go one at a time here. It looks like, nope, this isn't as bad as fractional exponents. Let's go. Audrey's like, man, those fractional exponents just suck all the fun out of math class. It is still your favorite subject though, right, Audrey? Answer carefully. Okay, I won't make you answer. How many got to this point at least? You've got these 4 possible roots. All right, how many already spotted the duplicate and X'd that out? All right, so that gives us 3 roots to check. How many have already checked your roots? All right, well, we're going to check because I haven't checked them yet. I got a -6 checking out. I've got a 2 checking out and a -2. I think is that checking out also?
Yeah.
Yeah, I've got the -2. I've got no extraneous roots. How many got all 3 of those checking out? Does anyone need to see the checking on any of them? Okay, so those who had the roots didn't get the checking. Questions? All right, go on to number 9. Leave it up there for just another minute if any of you have questions. But if you're good to go, move on to 9. Different, but you gotta have a +4.
Oh.
So then that outer ender is gonna be the -4. We just gotta change the signs, and that's gonna change the signs in the answers. That's what was happening. Because you got a +6, which wouldn't have checked. Number 9. If you finish early, go ahead and do 13 as well. How many realize you really only have two choices on number 9? You end up with a 2, there's 3 of them, and then a -2. You got those 3 2's and a -2? All right, we plug in the 2. I get 0 equals 0, so that one checks. When I plug in the -2, I get 8, -8. That does not check. That one's extraneous. How many found the -2 is extraneous? All right. Questions on number 9? Any questions on 9? All right. Get started on 13 unless you're already finished with 13. If you are finished with 13, go to 12. Now get your calculator ready if you get ahead to number 12. right, no extraneous roots on 13. How many also? No extraneous roots on 13, just a duplicate. Questions on that? Anyone need to see any of the checking worked out? Any of the process explained? Any questions on this before we hit 12, which is fun? How many have done 12 now? Yeah, it's fun, isn't it? All right, questions on this before we hit 12. All right, let's take a look at 12. So if you've already done it, you can sit there and just kind of check your work. If you haven't gotten to 12 yet, copy it down with me now, if you would, please. We've got the absolute value of k squared positive 7k is equal to negative 7k negative 45. So a whole lot of negativity, by the way. By the way, shortcut, if you want to check this, you know this has to come out positive, right? Because of this negative, if you get a really big value, anything bigger than 7, you're going to come up with a negative on this side. You can't have that. So nothing bigger than a 7 can possibly check. Well, nothing was bigger than a 7. Everything happened to check. But look at this. You better come up with a negative k value. So that negative times negative is positive, and it better be positive enough to overcome a negative 45. Do you see the mental process? This is positive. So it has to equal something positive. It's all negativity over here. So you're going to have a great deal of negative here. At least a negative 7-ish would put you on the positive end of things, right? Negative 6 wouldn't be enough. But negative 7-ish, if you don't understand that, don't worry about it. The check will take care of it. Just thinking out loud, math observation, anything that's not negative, any positive k's, I already know they're not going to work. Because positive and negative is going to be negative. Minus 45 is going to leave a negative on this side. You can't have that. All right, so we start like normal. We make our two equations. What are our two equations, Kendall?
K squared positive 7k equals negative 7 45. And k squared positive 7k equals positive 7k positive 45.
All right. And from here then, Michael?
You have to move it all to one side to get k squared plus 14k plus 45 equals 0. K squared minus 45 equals 0.
Good. Or we could just say k squared equals
Negative
45, couldn't we?
Yeah.
At this point, we have the complete quadratic. It's set equal to 0. We want to factor it up, Genesis.
K and K, both positive and 5.
Good. Add or interchecks. And then over here, it's an incomplete quadratic, Maddie. I've got to... And so that's going to give me k is equal to... Good job reducing the radical there. Positive negative 3 times the square root of 5. Now, remember something we pointed out before. This is why I wanted to point it out. When you see that much negativeness, it's going to make it hard for an answer to check. Here I get two possible k values. What are my two k values here?
Negative 9 and negative 5.
Again, without even coming over here yet, if I plug in a negative 5 class, negative 7 times negative 5, positive 35. Negative 45 gives me a... There's no way absolute value is going to be negative, right? I know without even plugging it in that the negative 5 isn't going to check. You follow? The negative 9 might, because negative 9, negative 7 class, positive 63. And 63 minus 45 is a positive 18. So let's check the negative 9 here. You square a negative 9. 7 times negative 9, negative 63. 81 minus 63. And the absolute value of 18 is 18. So the negative 9 does check. We come over here. This is where the calculator is going to come in handy. But positive anything times negative 7 class equals negative something. Minus 45 or negative 45 equals more negative something. And it's not going to. So I already know the positive 3 squared of 5 definitely can't check. But maybe the negative could. So here we go on the calculator. 3 times the square root of 5, and then stick a negative sign on that when you're done. Should give you something like negative 6.4-ish, maybe?
6.7.
Really? Okay, negative 6.7. All right. Times negative 7. Now we're up to what?
46.9.
46.9 blah, 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 minus 45.
1.9.
Give me a couple more digits. 1.957. Okay, that's enough digits, okay? Because it would be crazy coincidence for it to be that 3 digits and not be an exact match. All right, now coming over here. When you square that 3 times, or negative 3 times the square root of 5,
That's 5.
which is 45. And then the negative 3 times the square root of 5 times 7,
Negative 21 times square root of 5.
which is, on your calculator, negative 21 times the square root of 5.
46.
Negative 46.9 blah, blah, blah. Okay. Take what's on the calculator, negative 46.9 blah, 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 add a positive 45 to that. And what do you have?
1.957.
But we're going to take the absolute value of your negative 1.957, and sure enough, it will be 1.957, and that answer also checks out. So a negative 9 and a negative 3 times the square root of 5 checks out. Aren't you glad we were able to rule out the positive value just like that? Didn't even have to bother trying to plug that into the calculator a second time. All right. How many worked ahead and got those 2 answers? A couple of you did. Okay, good. Questions on that? Let's take a look at number 10 now. Yes, number 10. Absolute value v squared positive 4v equals negative 4v negative 12. And here's another with a double negative, so that's actually a good thing, right? Because then all those negatives allow us to quickly rule out possible answers. All right, 2 equations. Audrey?
V squared positive 8v positive 12 equals 0.
Okay, hold on. You're showing off now. All right. So she knows she's going to leave these signs alone. She's going to bring them over in her head, and you said v squared positive 8v positive 12 equals 0?
Yes.
Good, all right. All right, show off. And what's the next one going to be? I like it, though. I like it, though. You're lazy. I love your laziness. I admire it, Audrey. All right, so now when we change the signs, what do we get?
V squared positive 4v equals 4v plus 12.
But I was just sure you were going to cancel the 4 v's in your head. Yeah, so end up with a v squared equals 12. All right, does anyone need to see it worked out, or did you follow Audrey's brain there? Y'all following along with what she's doing? All right, how many are like, I could do that too? Yeah, Brandon's like, yeah, give me a chance. All right, on your homework, you can show off. All right, so of course we need to factor this side. Brandon, show off for us.
V plus 6 and V plus 2.
So we have 2 possible v's.
Negative 6 and negative 2.
And then here we're going to get a couple possible v's as well.
Positive and negative 2 times the square root of 3.
Good, and since last time I ran into a conundrum using that positive negative, I'm going to write them as separate values so it's easier to cross out an extraneous one. Which value, using the same logic we used here, which one has to be extraneous? No question. Okay, that's not to me as obvious, but that is true. Because a negative 2 times a negative 4 class is only positive 8.
Oh, yeah.
That's not enough positive to overcome all that negative. So it would stay a negative on that side. That's no help.
Yeah, positive 2 times.
Positive anything, right? I knew positive anything here would leave me with a negative, so I can rule out that one. So it only gives me 2 possible choices. Last time they both worked. Let's see if these both work. Let's start with the easy one, negative 6. Negative 4, negative 6, class. Positive 24, negative 12.
12.
All right, negative 6 when you square it.
36.
Negative 6, positive 4.
24.
Negative 24, 36, negative 24 is,
12.
and the absolute value of 12 is
12.
12. All right, so that one checked out. Calculators at the ready. Now, real quick, because 2 times the square root of 3 is hard, right? Where did this come from? It came from the square root of 12, right? Wouldn't it be easier just to type negative square root of 12 into the calculator? Now, this is not how we would leave our answer, but this is what we're going to type in the calculator. Just like square root of 45 would have been easier last time, right? So there's a little strategy tip for the check. Square root of 12, but make it negative. like negative 3.46 times negative 4.
13.85.
Now subtract 12 from that.
1.856.
1.856, someone corroborate his
Yeah.
story? All right. Now let's come over here. If you square the negative square root of 12, you're just going to get
Negative 12.
12. And then if you multiply negative square root of 12 times 4,
Negative 13.8.
but add a positive 12 to that.
Negative 1.856.
But its absolute value, which is going to change that negative back to a positive, and as we suspected, that's the way we'll leave the answer. Again, use the square root of 12 for the check because it's easier. So here, if we use the square root of 45 as a check, that's going to be easier. Does that make sense? Use the unreduced form in checking on the calculator, but for the answer, we'll leave the reduced form in the blank. Questions on this? All right, I want to just give you a preview of what is coming tomorrow. So just a little preview of what we're about to get into. Write this down on your paper if you would, please. X cubed negative 9x is equal to 2x squared negative 18. X cubed negative 9x equals 2x squared negative 18. You'll notice, first of all, this is not actually a quadratic. I've got a cube, it's a cubic equation. You also notice it's not in quadratic form because I couldn't factor anything in particular out to get it into a quadratic form. But for equations of higher power, even than a quadratic, generally we will set them equal to 0 and factor. And we can do that here as well. So with me, let's leave the highest power where it is and send the other stuff over to the other side to get what, Abby?
X cubed negative 2x squared negative 9x divided 18.
Good. And here my factoring isn't going to be backwards FOIL. What's my factoring going to be in a problem like this, anyone?
Grouping.
Grouping. There's 4 terms. All right, so in the first group, the common factor, Michael,
X squared.
and when I pull it out,
You get X minus 2.
and in the next grouping, Kendall,
9. Negative 9.
good. Whatever the first term has as its sign, that's what you're going to pull out. So at negative 9 leaves us with, be careful,
X negative 2.
good, x negative 2. And the nice thing is we have a common binomial factor now, Genesis. What's common to each term? What's in both terms?
X minus 2.
X minus 2. And we can factor out the x minus 2 to leave ourselves with,
X squared minus 1.
but we're not done factoring here. Though we could be. We could say, hey, I've got factors equal to 0. Let's just stop. Let's say here, class, x equals 2, and x squared equals,
Positive negative 3.
well, x squared equals
9.
9. He's trying to show off now. Trying to keep up with Audrey. Now we get x is positive negative 3. Notice 1, 2, 3 answers in the cubic. Seems easy enough, right? Set it equal to 0, factor by grouping, and there we go. But, try this one out. X cubed, positive 2x squared, negative 11x, negative 12 equals 0. Ooh, thoughts? It's not going to factor by grouping, is it? You could pull out the x squared out of the first group, but what are you going to pull out of the next group? A negative 1? I mean, you could, right? I mean, you know, it's not wrong, but there's now also not anything common. And that's what we're going to show tomorrow is a different process. So the fact set equal to 0 and factor has been working, and some cases it'll work. But what about when it doesn't? And tomorrow I'll teach you how to do those. Your homework for this evening is to do page 138. Page 138. The practice at the top of the page, numbers 1, 3, 6, 7, 11. 1, 3, 6, 7, 11 at the top of page 138. At the bottom of page 138, do the review 7 through 10. Page 138 at the bottom of the page, the review 7 through 10. We'll take a look at that tomorrow and then teach you a radically, not with radicals, but a radically different method to solving equations when they will not factor. Take a look at that tomorrow. Have a wonderful rest of your day, and when the bell rings, you'll be dismissed.